Hi guys, this is Vineet and I welcome you to this video. Today's video topic is indexes on computed columns in SQL Server. Before I proceed ahead guys, if you are new to this channel or if you are watching my channel from long period of time but not have yet subscribed to the channel, please go ahead and do so right now. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my upcoming videos. The reason I want you to subscribe to my channel is because I do not want you to miss on any of my videos. I do post videos on regular basis on SQL Server various topics. So right now this is a video on indexes, and previously as well I had created many videos on indexes, and this will add to that playlist. So please go ahead and subscribe. I am waiting. Let me give you 5 seconds to subscribe. Alright guys, I hope you must have subscribed by now. So guys, let's move ahead. There are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept. And if it's possible for you, please watch this video twice or as many times as you want until the concept gets clear to you. Perform any exercises in your test and lab environments only. Do not touch any production environment or production databases. We would like to know your thoughts regarding our video, so please do share your comments and suggestions or any reviews, any feedbacks, any stories. We eagerly wait for your stories and comments and would love to read the same. So do post in your comments, guys. We have created some playlists for you to watch. The reason why we create playlist for you is because we feel that playlists are best way to learn about any particular domain. For example, if we talk about this video belongs to the SQL Server indexing category, which already has 10 videos. So I will keep on adding videos to each and every playlist. Some of the popular playlists are SQL Server database design, SQL Server tables, business continuity, indexing, performance tuning, integration services, and transact SQL. So far, SQL Server database design is our larger playlist, having more than 80 videos. So if you want to learn about any particular area, playlists are very helpful. So for example, if you want to learn about database design, what we would recommend is go to the database design playlist, watch out all the videos from starting till the end if you want to gain mastery over that area. All the links for these playlists and my channel page link is given in the video description area of this video. So please go ahead and check out the video description area and go to the individual playlist link to watch out the videos. And you can also visit my channel page as well. And if you talk about the total number of videos posted on our channel, it's more than 230 videos at present. And number of videos are growing at constant pace on a daily basis. Now let's come back to today's topic, which will be this will be a theoretical topic. We will talk about indexes on computed columns in SQL Server. So I hope you have an idea on what the computed columns are. These are basically columns which are the result of values of any other columns. So these are computed on the fly, and basically we will talk about whether we can create indexes from the computed columns or not. You can read more about the computed columns online. If not, if we have a video, you can search out on my channel page. If not, yeah, you can read about the computed columns online. So far, in this video, we will discuss about whether you can create indexes on the computed columns in SQL Server, and most of this session will be theoretical. So let me take you to notes directly, and let's go through these notes. So today's topic is indexes on computed columns in SQL Server. And basically we can define indexes on the computed columns as long as these columns meet the following requirements. So there are certain categories of requirement. First set of requirements are ownership requirements. Then we have determinism requirements. Third we have, let me check. Third we have precision requirements. Fourth we have data type requirements. And we have set option requirements as well for the columns. And these all requirements determine whether we can create indexes on the computed columns. So let me deep dive into this theory. All right, you can write down the notes while I'm explaining them. So let's start with the ownership requirements. So basically, ownership requirements, let's read under that. So all function references in the computed column. So computed column is a result of values in the other columns. So all uh, it's a computed column is basically a result of the function of the values used in other columns. So all these function references in the computed column must have the same owner as the table. So whatever columns we are using for computing the values for the computed columns, the owner for those columns should be same as the owner of the computed column. That's the owner that comes under the ownership requirements. If we have to create an index, the column computed column formula should fulfill that purpose. The ownership requirements, whatever columns are used, should have the same owner as the owner of the computed columns. Now let's talk about the determinism requirements. So first of all, we will talk about what is deterministic thing. So basically we talk about an expression, maybe a plus b is an expression, example, or a equal to 2 is an expression as well. So we call an expression as deterministic if they always return the same result for a specified set of inputs. So if we talk about an expression, we call a particular expression deterministic if it always return the same set of result provided we give it a same set of inputs. And we can use the is deterministic property of the column property function. So we can use this function column property function, and we can use the is deterministic property of this column property function to determine whether a computed column has a deterministic value or not. This function can be used to basically report whether a computed column expression is deterministic. And this is the property we are talking about. It's the is deterministic property of this function, column property function. And basically, column is deterministic. It specifies whether a column is deterministic or not. And this property applies only to computed columns. So we can check this property for computed columns only and view columns as well. And if it results true, true basically indicates that the column is a deterministic column. Otherwise, if we get 0, then it means that column is not a deterministic column. And if we get null, that is because we have provided an invalid input and it's not a computed column or a view column. Now, the computed column expression must be deterministic. So your computed column should be deterministic, which can be true when all the following conditions are true. So these are the conditions when you are sure that your computed column is deterministic. All the functions that are referenced by the expression. So I'm talking about the expression for calculating value for the computed column. So all the functional references in the expression are deterministic. If they are deterministic and precise, the computed column will be deterministic. And these functions include both the user-defined functions and the built-in functions as well. And functions might be imprecise if the computed column is persisted. All right. Now, the third point is that all the columns that are referenced in the expression come from a table that contains the computed column. So, second thing for making a compute which makes the computed column deterministic is that whatever columns computed column is referring to are from the same table. That makes the computed column deterministic. Now, next point is that no column reference pull data from multiple rows. So basically, no particular column reference pulls data from the multiple rows. For example, if we talk about aggregate functions such as sum or average, they depend upon the data from multiple rows and would make a computed column expression non-deterministic. So if your computed column is using any of the functions like sum or average, then it will be a non-deterministic column. So your computed column should not use any aggregate functions. All right, if you want it to be a deterministic column, and if you want to put an index on that column, computed column, it should be deterministic. And there should not be a use of aggregate functions like sum and average. Let's move on to next point. The computer column expression has no system data access or user data access. This is another point. Your computer column expression should not have access to any system data or the user data. Now, any computer column that contains a CLR expression must be deterministic and marked persisted before a column can be indexed. We will talk about CLR expressions later. So any computer columns that contains a common language runtime expression must be deterministic, and they should be marked persisted before columns can be reindexed or indexed. And CLR user-defined type expressions, we will talk about them later. We will create a separate video for them for CLR user-defined expressions. So if we talk about CLR user-defined expressions, these are allowed in the computer columns definitions. And computed columns whose type is a CLR user-defined type can be indexed as long as the type ID is comparable. Now let's talk about the casting and converting used in the computer column. And when we refer to string literals of the date data type in index computer columns, we are talking about the string literals of a date if it is used in the computer columns in SQL Server. Recommendation is that you explicitly convert the literal to the date type that you want by using a deterministic date format style. Alright, so this is regarding the string literals of date we use in computer columns. The recommendation is to cast them to a date type by using a deterministic date format style. Now let's talk about the compatibility level. So any type of implicit conversions of non-Unicode characters data between collation is considered non-deterministic. So any conversions happen due to the mismatch of collations and any conversions of non-Unicode character data that happens due to mismatch collations is considered non-deterministic unless the compatibility level is set to 80 or earlier. Compatibility level 90 corresponds to SQL Server 2005. Now when the database compatibility level setting is 90, you cannot create indexes on computed columns. Alright, so if your setting level is 90, which corresponds to SQL Server 2005, you cannot create indexes on the computer columns that contains these expressions. However, existing computer columns that contain these expressions from the updated database are maintainable. Now, if you index computer columns that contain implicit strings to date conversions, to avoid possible index corruption, make sure that the language and date format settings are consistent in your databases and applications. Alright, let's move on to the next point. Let's talk about the precision requirements. So far we have talked about the determinism requirements and the ownership requirements, and now we are talking about the precision requirements. So if we talk about the computed column expression, the expression which is used to compute the computer column, so the computer column expression must be precise, so it should give a precise result. A computed column expression is precise when one or more of the following is true. So when does a computer column expression becomes precise? Whenever we meet one or more of the following conditions. It shouldn't be an expression of a float or real data type. So an expression can be precise if it does not use a float or real data type, and it doesn't use a float or real data type in its definition as well. For example, in the following statement, let's consider this statement where we are creating a table. So guys, there is a little bit correction to the code. So here we don't have a bracket, so instead we have a comma. We have following columns now. A is integer type column, B is integer type column, C is integer type column, X is float type column. And if we talk in regards to Y, this is column we are taking as case X. The value of column Y depends upon the value of X. We are taking Y as case X. If the X value is 0, then the value of Y column will be A, and the value of X is 1, then the column of value of column Y will be B, and else the value of column Y will be C. So here we were talking that in this example, in the following statement, column Y is integer. So this is an integer type column and it's deterministic as well. because it is taking values from a deterministic column A, B, and C only. But this is not precise as it is using case x and x is a floating point value. So y is not precise here. Now, float or real expression is considered imprecise. So if we talk about float and real expressions, these are considered imprecise and cannot be a key of an index. So we should not use the float expressions in the computer column in case we want to put an index on that column. Now, float or real expression can be used in an indexed view, but not as a key. All right. So we can use float and real expressions, but again, we cannot define an index on that computer column. And this is also true for computer columns. Any functions, expression, or user-defined function is considered imprecise if it contains any float or real expressions. And this includes logical ones, comparisons, etc. The is precise property is there's a precise property as well of a column property function, and basically that reports about the whether that particular compute column expression is precise or not. Now let's talk about the data type requirements for creating indexes on the computer columns. So what is the data type requirements? Again, the computer column expression defined for the computed column can't evaluate to text. So this computed expression should not evaluate to text. It should evaluate to a number, but not to a text, and text or image data types. That is the condition for the data type requirements. So again, the data type, the computer column expression should not evaluate to text and text or image data types. And computer columns derived from image and text varchar max and varchar max, var binary max, and XML types can be indexed as long as the computer column data type is allowable in the index key columns. If we are using any of the columns which have for a computer columns, if we are using any of the columns of these types, image and text, varchar max and var binary max, and XML types, these computer column can be indexed as long as the computed column data type is allowable in the index key column. So the source column can be these columns, but ultimately the result of the computer column should be an integer value, right? Not the floating point value, not the text value, not the end text value, or not the image value, nor any binary data. So for computer columns, the output should be integer data type if you want to create an index on that particular column. Now, computer columns derived from image and text data types can be non-key columns, which means that index cannot be created on those computer columns. So if we derived any of the computer columns from image and text data type columns, then these can be a non-key columns or included columns in the non-clustered index. These can be used, and these computer columns still can be used as included columns in the non-clustered index, but we cannot use them as these computer columns as to create a cluster index on them. But yeah, these columns can be used as included columns for any non-cluster indexes as long as the computer data type is allowable as a non-key index column. Now there are certain set options requirement as well. So let me talk about that. So if we talk about set options requirement, the ANSI null connection level option must be set to on. So if we want to create a computed index on a computer column, this ANSI null connection level option should be set to on when the create table or alter table statement that defines the computer column is executed. This option should be turned on at that time. The object property functions report whether the option is on through the is ANSI null on property. So we can use this function with this property is ANSI null on to verify whether this property is turned on before we create any table or alternate table. Now the connection on which the index is created, we are talking about the session connection. So the connection or the session on which the index is created, and all connections trying insert, update, and delete statements that will change the values in the index must have 6 options set to on and 1 option set to off. The optimizer ignores an index on a computer column for any select statement executed by the connection that doesn't have these same option settings. Any of the connections on which the index is created and all the connections trying to basically insert, update, and delete data inside that table containing the computer column. So any of these statements that will change the value in the index column must have 6 options set to on and 1 option set to off. We'll talk about these options later. The optimizer, query optimizer, if we talk about, will ignore an index on the computer column for any select statement executed by the connection that doesn't have these same option settings, which means 6 settings should be turned on and 1 should be turned off, and these are the settings which should be turned on. So the numeric roundabout option must be set to off. So this is the first option which should be set to off, and the following options should be set to on: ANSI null, ANSI padding, ANSI warnings, arith abort, contact null yield. It's not contact, it's concat. This is the function contact null yields null. This is the option which can be set to on or off. So these options should be set to on, and the last one is the code identifier. These 6 settings should be set to on, and this numeric roundabout should be set to off. We want the optimizer to consider index while we execute any select statements against those computed columns if we have an index defined on it. In order for optimizer to use the index, these 6 settings should be turned on, and one of the settings should be turned off, which is numeric roundabout option. Next topic is create indexes on persisted computed columns. Let's talk about that. Now, sometimes we create a computed column that is defined with an expression that is deterministic yet imprecise. So sometimes we do create a computed column which is basically a result of the expression that is a deterministic expression, but here the result should be imprecise. We can do this when the column is marked persisted in the create table or alter table statement. All right. This means that the database engine stores the computed value in the table and updates them when any other column on which the computer column depends are updated. The database engine uses persisted values when it creates an index on the column and when the index is referenced in the query. All right. So let me take you through these points. So sometimes we do create a computed column, and that is basically defined with an expression, and that expression is deterministic, but it is imprecise. All right. And we can do this when that particular computed column is marked persisted in the create table statement or alter table statement. Only in those cases we can create that computed column using an imprecise expression. And this means that the database engine stores if we mark a computed column as persisted, right, then the database engine will basically store the computed column values in the table. The database engine stores the computed values in the table itself. If the persisted value is turned on for a computed column, the database engine will store the computed columns, whatever they will be, in the table and updates them when any other column on which the computed column is based gets updated. The database engine uses this persisted value when it creates an index on the column. So database engine will use these persisted value in the computed columns while creating any indexes and when the index is referenced in the query. Now this option basically enables you to create an index on the computed column when database engine can't provide with the accuracy where the function that returns the computed column expression, particularly a CLR function that is created in .NET Framework, is both deterministic and precise. So another option is to mark the computer column as persisted if we want to create an index on it, even though these column may contain values which are deterministic but not yet imprecise. All right. So guys, we are done with this topic. I hope you like this video. In today's video, we have talked about the requirements for creating an indexes on the computer columns in SQL Server. So there are certain ownership requirements, determinism requirements, and we have then precision requirements. And other than that, we have data type requirements, and we have set options requirement as well. And we also talked about creating indexes on persisted computer columns, the computer columns which are specifically marked as persisted. So those persisted computer columns can allow any imprecise values as well. But otherwise, if they are not marked as persisted, then they will not allow. We cannot create an index on such columns until they are persisted column contain an imprecise values as well. Otherwise, the values of the computer column should be precise and deterministic if we want to create an index on them. So that is the gist basically. So guys, I hope you like this video, and we will be creating more video indexing which will come in upcoming days. So stay tuned with us, and if you haven't yet subscribed to this channel, guys, please go ahead and do so. There is a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my upcoming videos on indexes. So far we have around 10 videos on indexes. This is the 11th one, and we will be creating quite few more in the upcoming days, as I have to cover and complete the indexing topic. So stay in tune, keep subscribed if you want to get the timely notifications. Otherwise you will miss upon some of the notifications regarding my videos on indexing. So I hope you have subscribed by now. And guys, do post in your comments and any stories. We love to read your comments and stories, so do post in. And guys, if you have a good network of friends, please ask your friend to subscribe to my channel and also share my videos with them if they work in SQL Server domain, and if you feel my videos and channel can make difference in their life. Yeah, do share my videos with them and do ask them to subscribe to my channel. I thank you so much for your time today, guys, and you have a wonderful day ahead. Thank you.